So this recorded, when I do a recording like this, I'll save it to my YouTube channel and then I'll post the link. And so you can see what's sort of happened. I don't know if you guys like that. I might do that with all lectures. I don't really mind. It's easy enough for me. And that way you've got a history of it. So you can go back and look at it later. Maybe you don't want to look at it. So the way D2L looks, so some of you guys are new students maybe, so you might not have seen stuff. I can't believe there's nothing in there. What? All right, okay. Yeah, there it is. Just there. So you've got this course syllabus that you can sort of look at and you can download it. Maybe I'll do that, download it, get it bigger on the screen. The course syllabus is basically explaining what we're expecting from the course. As I said, it's a new course, but so we're tweaking it as we go a little bit. Not too much. I mean, within we're not changing it. None of this stuff was changed, but just the actual way we deliver it a little bit changed from last time. So there's a little bit of information about that. Notice I'm not handing these out as physical copies. You know, save the planet, that kind of thing, right? You're just going to throw them away, right? Were you going to read them? So I mean, it's all on here. If somebody desperately needs to have paper, just ask me later and I'll print them out. But you know, just to have a big stack of them to throw away, I don't think I need that. So there is actually there a timeline of what we're doing in some very nice things there. So students are always asking, you know, well, how much is this worth? How much is that worth? So you can see from here how much each thing is worth. So your final exam is 30% of the course. You got 2 tests, which make a total of 40%. So they're actually worth more than the final, right? But added together. So they're 20% each. So they're big things. They're no messing around. Quizzes, which we're going to have fairly regularly, like every other week. So we've got like 6 to 12 or 16 weeks, something 14 maybe. So we're going to have 6 or 7 quizzes. And they're a little less stressful than the tests and a little bit more open environment. That's fine, but that's to sort of get you ready for it. Assignments, 10%, and labs. And the labs you have to do in class, the assignments you do at home. Right, so they're not big in terms of the marks that you get from them, but you know, those are easy marks. You really ought to do it. You know, they pick up those marks. People tend to, well, just by experience, you can see that I'm kind of old. So I've been doing this for a while. And what I notice is students tend to get better marks on the quizzes, sorry, not the quizzes, on the assignments and labs than they do on the other things. You know, here you can ask the teacher, you know, that kind of thing. So it's really worth doing it. And there you have a sequence, which is you can see what we're doing when in this course. We do have a bit of an introduction to computing to get going in this first lesson. So the first lesson might seem a bit strange. You know, why am I having a history class? I don't know. People like to put things in context. Yeah, so I mean, you know, that's what I'm going to say. History, yeah, just so that we know what is the environment we're working in this IT thing. So there's not too much sort of logical mathematical thinking, which we tend to rely on a little bit more in our later lessons. And so then you can see how that's broken down there. And there's some rules. Probably worthwhile looking at those rules. I thought this one was interesting. I hadn't seen that sort of before, but yeah, you do need to have something in your control that you have a full admin rights for. And I need to say this here, right? So we have in the college, we've divided up different rooms in the department here, IT. So we have two different ways of setting up the rooms. We have what we call the program rooms, and they are strictly controlled by the IT department down there. What that means is admin rights are not shared with teachers or students. And so those, whatever you see on there is strictly controlled by that. If we want to put anything on those computers, we have to go through a process and get permissions, et cetera. And that takes time, right? And so that means we can't just come in here and start installing our software. You know what I mean? You can't do that. And that's for security reasons. Otherwise, you know, the computers would soon get out of control. and they wouldn't be able to maintain them. We have other rooms which are VLAN rooms, which are under control of our teaching department. And if you're in a VLAN room, then you will have admin rights. You can install software and play with it, mess with it, no problem. I don't know if this is a VLAN room or a production room. I think it's probably a production room. So what that means is we actually have some software that you have to use in this class. And that means you need to install it. And we're not going to go around and begging at the IT department so that they'll install software. Sorry, so you need to have a computer that you can install some software on, all right? Is that fair? I don't know. They might. So, for example, the software that I'm talking about is we need to be able to use this software called IDLE. It's an environment for the Python programming language. It's a development environment for that, and so it's free. You can download it from the internet and put it on any computer you want, but you have to have admin rights. Okay, so if we're in a VLAN room, that wouldn't be a problem, but if we're in a production room, it might be. There's other stuff there about coming to class and stuff like that. Late submission, plagiarism. Basically, don't hand in anybody else's work in any way. And yeah, so that's worth you looking at. I do have my timetable there, so you see there the light blue. Those are office hours. So I tried to make it at times when people are around, I suppose. You see, I'm teaching now, and I got this 5-hour break. I suppose sometime you might find me in there. I'll be around, but I will be sitting in my office on the blue times. Okay, I don't mind talking to students too much, but yeah. So there's office times, and now your class, this class here, you're the green class, right? So we have this lesson, then we have. So you see, we have a lecture today, a tutorial tomorrow at 5 o'clock. Yeah. Well, look, I got a class that finishes at 8 tonight. I mean, what the brave new world. Okay, so that's that. Any questions? So you know how you're going to be assessed. We're going to have the big exam. We're going to have the quizzes. We're going to have all that. You can look at that paper afterwards. Not paper, but yeah. All right, so let's talk about lectures then. Let's talk about history. You guys like history? Oh, okay, cool. I like history a lot. I'm not really into I am into modern history, but is there any way of me getting that off to the side there? I don't know. Yes. There we go. History of computing. So let's go. As the first slide shows there, a couple thousand years ago, some little mechanical devices, you may have seen these, abacus, were developed. A couple hundred years ago, we had a slide rule. Actually, when I went to high school when I was like 15 years old, we used to have we had to buy this table. It was called table of logs, logarithmic functions, tan, cosine, secant, all that kind of stuff, logs. And then we had a slide rule. That's how we did all our math, with a slide rule. Oh, it tells you how old I am, right? That was before calculators. And I was so excited my first year of university, and I went to the student union, and they had these electronic calculators. I'm like, whoa, look at that. You just push the buttons. Man, that's so good. That's so much easier than that slide rule. I threw away the slide rule when I got the electronic calculator. Yeah, that was great. So Babbage, he's sort of all of these things is before electric, right? So before electric stuff, they're still using little devices to do computing. Babbage came up with something in the 1830s. No real electricity and stuff like that. We got a nice picture of one there. Hollerith, United States, always wanting to know how many people they got. And so that's been a problem forever. And Hollerith came up with a little system in 1880 that we'll talk about in a minute. Transistors, the idea of a transistor, you'll see a photo here in a minute of a vacuum tube. When I was a kid in the 50s, 60s, when we watched, our TVs would glow hot, right? You turn on the TV and take like 2 minutes for it to warm up, and then there'd be this little light come out of the middle, and then it'd spread to the Yeah, because it had to get to the right temperature before it would work. Okay, because they were using tubes, and in the back everything was vacuum tubes too. It has to warm up. Use a lot of electricity. So the transistor was got over that, right? Instead of having a bunch of vacuum tubes, it took up a lot of space, produced a lot of heat, and broke all the time. They came up with transistor in, what is that, 1947. I mean, it really became sort of popular and used everywhere. People started using transistor radios in the 1960s. And then, of course, this thing here, yeah, that's about when I started doing computing, is when this came onto people's desks, the Apple Mac. And the exciting thing about that is it had a graphical user interface, which means instead of having to type everything in a command line, you could use a mouse. All right, so we've got these we've got this terms computers, computing. You might be interested to know that the first time that they used the word computer, they're talking about a person. All right, so a computer was somebody sat in somebody's office and added things up. Yeah, kind of like an accountant, I suppose, but maybe without the proper training to be an accountant, just sort of added things up. The process of calculating is computing, computation. It wasn't always just to do with, as we see, some box that we carry around. And actually, yeah, so computing nowadays, is much broader than the sort of box that you see on your desk, right? I would call this a computer. In fact, the processors in this are much more powerful than the first computers that I ever used. I mean, this does lots of cool stuff. Yeah, I can run programs on this. I could write Python programs on this, no problem at all. I could download a Python interpreter on here and start writing programs, no problem at all. You can do database programs on here. You can do web development on here. I mean, why would you, right? It's much easier to do it on a desktop. But there's a lot of power in that machine, quite a lot more than, if you look at this history, the people who some of them are still alive, would have looked at the mobile phone and said, never would have been able to imagine it just 20 years ago. Like, you're kidding. People walk around with a computer in their pocket that's able to do all that stuff. No way. But it is. All right, so the abacus, as I said, it's got a long history. So here in our notes, it's claiming that it's 5th century Greek. So 5th century BC, that means 2,500 years ago. That's interesting. Chinese use them, also been around in lots of other places, Afghanistan, apparently. I didn't know about those things. So that, if you're interested in that, that might be something that you'd look at. All right, so we're getting to a bit more modern. So this is only, what, 400 years, less than 400 years ago. Got this machine, Pascaline. So we got this guy by the name of Blaise Pascal, and that's why this name comes up. These things were named after him. He was living around that time, French guy. He was a mathematician. And so he was a mathematician, but like a lot of these sort of scientists, mathematicians back in those days, yeah, he was interested in lots of sort of things. And so kind of like an engineer mathematician, right? And so he made these machines that's able to do some calculating. This guy Leibniz, also pretty interesting. I guess you guys have to do a course in calculus. Am I right? Isn't that exciting? The Principe of Calculus, I think, was a book written by Isaac Newton at about this time, 16 something. And Isaac Newton, you might be interested, this history, I find this history interesting. Isaac Newton in 1660, something like that, he was at Oxford University or Cambridge, I can't remember which one of those. And he had to stay home. Why did he have to stay home? Because they had a pandemic. And he couldn't go to classes. They closed the university for like 2 years. And so he's sitting at home. What am I going to do while I'm home? Oh, I know. I'll invent the calculus. And that's what he did. And he wrote, a pretty smart guy, right? I can't go to university, so what I'll do? I'll invent the calculus. And so he invented the calculus and he put that down. But the thing is, there's unknown to him, or maybe known to him, I don't know. In Germany, there's this guy named Leibniz. And what did Leibniz do? I don't know. Maybe he wasn't writing too many letters to Isaac Newton, but he also invented the calculus. All right, so it was done by more than one guy. In addition to inventing the calculus, he created a little machine that could do additions and stuff like that. That's what Leibniz did. So as I said, these guys do more than one thing. And Isaac Newton did more than one thing too, didn't he? I mean, he invented the calculus, but what else did he? Oh, that's right. He discovered gravity and stuff like that. I mean, these guys are pretty amazing, right? Or not discovered gravity, but I mean, he described it in mathematical terms so that we could go and work with it. And of course, everybody who does first year first year physics uses the understanding that Isaac Newton had about gravity. You know, so they have this special G factor that they sort of put into their calculations. All right, so Jacquard's loom. Now, what's cool about Jacquard's loom is he's doing little punch holes on a card, and doing these little punch holes on a card determines which string is going to go after which string, right? So this making fabrics by putting strands of the fabric over each other, loom, that's what it does. That's been around forever. Now, as I said, I like history. This is one of the histories that I like, that Greek history. It's funny, you know, I read a bit of those Greek books. I never heard about the abacus, but apparently. But what I did hear about is their weaving. They did a lot of weaving, and they described the weaving of the Egyptians as opposed to the weaving of the Spartans. And you know, the Spartans were weird because they started at the bottom and went up, and the others started at the top and went down, something like that. Anyway, so they took a lot of they really cared about their weaving, and you know, that was the other thing. Like this, they all wore these beautiful linen clothes, but the Spartans would wear wool, except for they wear it over top of the linen. But there was something about it. They couldn't wear it in public or something. That was only at home or something like that. Anyways, if you're interested in that history, you can look at that too. Charles Babbage. Oh, we're running out of time. So what am I going to do? So don't worry, students. If anybody's listening on the other end of this, I'll start as soon as this stops, I'll start another one. Well, maybe I should do that now, right? Okay, so you guys bear with me for this. Because so when I stop the share, that's been recording. There's only Lojane there. Oh no, it's Lojane and Sahar. Hi, Lojane and Sahar. So I'm going to end this, and then we're going to start again.